Okay, so a very good evening to everyone who's present here today, all my programming members. It's an absolute honor to welcome you to this much awaited finale of ML Challenge. And I'm truly privileged that I get to be your host today evening. Uh, I think ML Challenge has become an event that does not need any introductions. It's a platform for all programming enthusiasts, whether you're a beginner or a foundation level student or advancing through your degree. I believe that I speak for everyone who's present here when I say that each person has gained invaluable experience throughout this week, whether it's tackling challenges or it's solving real world dynamics or it's showcasing your prowess in NLP or ML or collaborative ideas with peers. From everything, I think all of you have come a really long way. And here we are at the pinnacle of this challenge, where the top 18 teams will finally present their work and share their experience for the ML challenge. And we are, as hosts, we are ready to reignite your passion for programming, AI, and ML once again. Before we proceed, I think it's my pleasure to introduce our esteemed guests for the evening, Kothai ma'am and Mr. Piyush Vairali, and we are thrilled to have you with us. I would like my event head Somshubro De to extend a formal welcome to both the guests.
Yeah, sure. So I see that Kothai ma'am has already like joined the meet. So basically, over to you, like ma'am. So like, could you like speak a few words for the event? And thanks a
Okay,
lot for joining.
yeah,
This schedule.
you're welcome. Good evening, everyone. I think today is a concluding session on your ML challenge. And I'm not going to take much of your time because everyone is curious to know to, uh, look into the presentation of the participants. And so I would like to say I'm very proud of our team, Wayanad House, uh, which has organized this event. And I'll also welcome Piyush, your course instructor, who is part of this event. And yeah, that's it. You guys go ahead. I'm waiting to watch what you have done. Thank you.
Thanks a lot, ma'am.
Yeah.
Thanks a lot.
Thank you so much, ma'am. We are truly honored, sir, to have you with us, and ma'am, eagerly await all of your wisdom for this journey. Anyway, participants, please be assured that sir will be answering all your individual doubts and queries towards the end of the session. So please have patience and wait until then. And I also want to take a moment to express my gratitude to my fellow organizers. Thank you so much. Without you, this journey would have actually been
I'll just
quite
like
hopeless. So thank you so
I'll
much.
just like share the
Right.
screen for a
Yeah,
quick
we can begin with the presentation.
for a quick overview of like what the challenge like was throughout the 7 day throughout this week. So is a screen like visible? Can anyone confirm? Shamini?
Yes, it's visible.
It's visible. Okay. So here we go. The Pan BSc IML challenge. So we had two like tracks. So in like short, both were the classification tasks. So the first task was basically where we had to detect the fake news in the Malayalam language, and basically it was a multi-class classification where also the participants had to predict the extent of how basically true the news like was, and like not only the binary like classification, like either the true or some false news. And for the second track, we had a very interesting thing, that is the participants had to like detect that whether a certain provided article was like AI generated, say like using say LLMs or certain tools like a GPT and all, or basically whether it was human like written. And basically this was a binary classification task. So here goes our event statistics, where we had a total of 183 teams, but there was a bit of imbalance in the split. That is 127 of the teams had like participated in the track 2, and only like 56 in the track 1. And we had overwhelming participant strength. It is like 342. We have hosted 5 mentor sessions throughout this time period, and we have like started from the scratch. So like we are very proud to announce that even foundation level students have like participated, and the majority were them. Now, out of these students, we are very happy that 2 of the foundation level students who were very new to the ML and AI like field have successfully like made it to the final like round with the help of the mentor sessions. So I wish them the very best that they have started like learning this, and I hope that it was a very good hands-on like experience like for them. And like today we have 12 teams from the track 2 and 6 for the track 1 who have like qualified for this final round. Just a minute. Sorry. So this is a like a humor that I think this resembles the actual thing, that is the team of participants like before and after the mentor sessions. I hope that participants should agree to this to some extent, I believe. So like this was the event flow where we started on the August 4th. So we had like released the problem statement along with the train set as well as the milestones, also the resources. And on August like 7th, so the training like phase was for like 3 days. On the 7th of August, we have like released the unlabeled like the test set, which like does not consist of the ground truth labels. So the participants had to train their models and then like test it on this set. And from August 8th to the August like 9th, we have like allowed the run submission on our own dedicated event portal. And we have allowed the 3 like run like submissions, out of which the best was like considered. So we have like considered the macro F1 as well as the accuracy metric scores for this challenge. So here are our top achievers. So like these 6 for the track 1, a huge round of like clap for them, I believe. Congrats to all the 6 people. It was a really hard task. As you can see that the highest F1 score is just like 0.4. So you know that how tough this task like was. There were like lots of like nuances in this task as well. And here we go to the track 2, where like these are the top 12 teams. Congrats to them as well. And here was our portal where we had put all the resources over here. So like there was a development phase, a submission phase, and also a tab to like basically check the performance as well. So like this was the testing phase where they had to upload the model. Just like the Seek portal is there for the IITM. So we had basically tried to build a similar portal. Yeah, so like that's it. Now I believe it's almost time. We can start with the presentations. And also thanks a lot like Piyush sir for like joining today. Thanks a lot for accepting the invitation. It's always happy to see you. Sir, you are not audible. Is sir audible?
No, sir is not audible.
No.
Hello. Now, am I audible?
Yes, sir, you're audible.
Yes.
Yeah, okay. Thank you, Som Subra and entire Wayanad House team for inviting me. And yeah, great to see more than 300 participants for this particular event. And yeah, as you said, foundation level students are also there, right? So yeah, looking forward to this particular event and presentation. But one more thing, like while you are starting the presentation, please introduce yourself, like from which level you are in current. Okay, so currently you are in which level, and whether you have done your MLP, MLT, or machine learning courses or not. Okay, so these 2 things, and then you can just start. Okay, I hope I'm audible, right?
Yes, sir, you are audible.
Okay, great.
Yes,
Yeah. Yeah, I think we can start. Yeah.
Yeah, so the first team, please start.
Uh,
Atish,
Atish Sivakumar and Parashmani Datta. I
yeah,
think we can begin with your presentation first.
Parashmani,
uh,
is she like able to like share the screen? Is she able to like share it? You
is
can't
Atish
share?
there? Yeah, is Atish there? Atish should be sharing the screen because the PPT he will be sharing. Uh,
If you're not
We can-
ready, we can
I can
come
go
back
with
to
the
you
next
later.
team.
Yeah, we can just
We can go to
come.
the next team.
We can switch to the next one.
All right. So the next team, which is Sai Rutvik and Shankha Subra Shaha, you can begin with your presentation. Are both of you
Am I
here?
audible?
yes,
Yes, you
You
are.
are
Okay,
audible.
okay. Then we can go ahead with the first presentation.
1 second.
Okay. So the first presentation.
Is my screen visible?
Yes, you can go ahead.
1 second.
Yes, it's visible.
Okay. Good evening, everyone. IITM organizers and all are present here. I am Atish Shivkumaran.
I am Parashmani, and we are excited that we got the opportunity to be in the final round. It is due to our joint efforts where we both worked as a teammate, and no doubt, Atish did a lot of hard work to reach to the final round.
In this presentation, we'll walk you through our approaches, methodologies, and findings. We'll start with the pre-processing. Okay, as for the pre-processing is concerned, the first what we noticed was we had symbols like these, and it might seem silly, but there was evidence that it would affect the tokenization, so we converted it to its appropriate forms. Then readability, AI generated text has like limited vocabulary, whereas human generated has a diverse set of vocabulary, which made us realize that like the model would be able to predict AI generated with a few instances. And for tokenization, we use GPT-2. Thanks for listening. Parashmani will walk you through hyperparameter tuning and model selection. Parashmani, you're up. Parashmani. Parashmani. Guys, am I audible?
Just a note to
Yes,
the
you are.
participants. Yes, you're audible. Sir had actually told that before starting, you have to mention which level you are in,
Okay,
etc.
sorry, I
So
had
just
some
all
screen sharing.
participants just take a note of it.
Okay, like my MLP projects, right? Actually, I am doing my MLP course right now. I haven't done any projects regarding to data science.
Okay, and I have completed the MLP course and last year. Okay, I'm right now in the diploma. Only 2 and 3 courses are. Two courses are only remaining. Okay, I have completed the data science. I'm now with a diploma in programming. Am I
Yeah.
audible? Yeah.
Yes, yes, you're audible.
Okay, so I'll start with the model selection. Now, after pre-processing, the main step or the next step that I shall say that is model selection. Now, it is very difficult to choose which algorithm correctly fits into the data set, as we had very limited submission availability to check how our model performing on this test data set. Since we had 3 options, what we did, we first tried with TF-ID to check whether it overfits or not. And what happened? The result is yes. Now, what is this TF-ID basically? TF-ID stands for term frequency inverse document frequency. Now, term frequency means the number of times a term appears in a document. And inverse document frequency, it is the logarithm of total number of documents in the corpus divided by the number of documents containing the term. Now, these are all like black box model, means it happens inside the model, I shall say. And what we get the TF-ID score. And this product of TF and IDF for each term gives us the weight that signifies the term's importance in the document. But what we find that there are some weaknesses in the TF-ID. Our score was like 56 and 56 point something accuracy. And then we realized that there something must be lacking in our model. And what were the weakness that were there in the model? TF-ID does not capture the context of the words within a sentence, which means it can misinterpret word importance in different contexts. And also TF-ID does not adapt to new data or concepts beyond the training data set. So what was the options left? Now there are so many models. So what we did, we tried with BART, we tried with GPT, and my friend Atish said that you try with BART and I will try with GPT. So we tried with BART. Now, what is this BART basically? BART is called bidirectional encoder representation from transformers. Okay, and it generates embeddings that capture the context of each word in a sentence, which leads to more nuanced understanding of the text. Now, suppose if I ask you that I am giving you a sentence like the animal did not cross the street because it was too wide. If I ask you that what does this it means, whether it's animal or the street, if anyone is there, you can say. I can repeat the line once more. The animal did not cross the street because it was too wide. What this it represents, the animal or the street?
Can be both.
Can be both, yeah. Okay, so it's like human recognition. We are saying it can be both. Now, what BART determines? BART is determining the prior word in the sentence, the word it refers to, then using the self-attention mechanism to weigh the options. The word with the highest calculated score is deemed the correct association. And in this example, it refers to the animal and not street. So you can easily say that BART how much is helpful. And it is also called a transfer learning model, pre-trained on large corpora, as well as the meanings is based on the context. So what we did, we used BART and then we fine-tuned this BART on specific tasks to improve the performance. Okay. Now, okay, Atish, change the slide. We'll go to the hypertuning. Okay, see what was happening with the different performance of the models. When we use TF-ID with LR, you can see the macro F1 score and the accuracy. How with changing of the models, the macro F1 has increased, and at the last you can see with GP2 with LR, when we did the undersampling, it is more or less 97 and 98, and that is the best accuracy that we have got. Okay, so next slide. Now this is the main part, because otherwise without hypertuning we cannot say like which model fits the best. Now when we did that, we found out that the C values from 0.01 to 100, okay, we actually started a grid search, and then we use this, and we found out that the degree for 2 and 3, when we have taken it, we found out the polynomial degree of 2 is the best for the C value of 10. Okay, and this improvement in the predictive performance has enhanced the model ability to capture complex feature interaction. Okay, Atish, you can take the lead.
Okay, the training process, as we had an imbalanced data set, we employed stratified train test splits. So it ensured that the class distribution was maintained both in the train test split and the cross validation, we did the same. Like we use a stratified cross validation. So all the folds were preserved the class distribution. Next, this is how we handled imbalanced data sets. Like as we anticipated, we found that oversampling techniques like SMART are ineffective for our text data due to their inability to generate realistic synthetic text samples, and it also may not capture the nuances of vectorized text data, which can have complex structures and relationships. So as we anticipated, the models showed us poor results, especially in that AI generated class, which had like very fewer samples. Only fewer samples were given to us. This led to many misclassifications, like many AI generated samples were classified as human generated, because we had many human generated samples, like it's sort of misclassified due to the overfitting on that class. So, and to address this issue, we undersampled, and it greatly helped improve our F1 scores and accuracies, as it was shown in the graph before. Next, the challenges, like Google Colab.
Participants, I would just like to interrupt for 1 second. For each presentation, you have 3 minutes only. So
Yeah.
kindly hurry up. Okay.
Yeah. Okay, for collab, like it often led to crashes, like it slowed down our working, and the main challenge was the class imbalance. Due to that, it actually messed with our classifications, and I earlier said there were so many misclassifications. Thank you. That's been our time. Any questions?
Yeah, hi Atish.
Hi.
So we are focusing on track 2, right? So AI detection of.
Yes, sir. Yes.
Okay. So okay, let me ask you one thing.
Yeah.
Suppose I have generated an article using AI. So
Okay.
if your model is able to predict it correctly means I have generated that article, but your model, okay, but your model said it is not AI generated. Okay, this is the first case. My article is AI generated, but your model is saying it is not generated. Second case is that my article is not AI generated, it is entirely human written, but your model is saying that it is AI generated. So which of the scenario is more important for you?
So actually, so sorry, can you repeat it?
Okay, so we have two scenarios. First thing is that AI generated article is there, but your model is predicting that it is not AI generated. Okay.
Okay.
Second thing is that in second scenario, uh, entire article is human written, but your model is saying that it is AI generated. So how you are going to deal with this both the scenario? Which one you are going to focus more on?
I think both are pretty important. Like if you see the real life applications, let's say a guy submitted an assignment fully generated using AI. If it's not correctly classified, then it might lead to him getting getting into problems. Not problems exactly, like getting false precisions. Then the second thing is like if a guy has done hard work and if you classify it as AI, that is gonna be, that's gonna give you a lot of trouble. I think both are important.
Okay. So what is your evaluation metrics?
I didn't get you, sir.
What is your performance metrics?
Metrics. 1 second. The last one is what we submitted.
F1 score is okay. Accuracy is this one. So
And
last one is GP2 with LR, right?
yeah, and I also like to acknowledge that the undersampling worked. Like even though we reduced from 386 samples of human written samples to 144, it did pretty good on classifying human written text. So I think that is a good thing.
Okay. So how did you split your training dataset into a validation dataset?
So we used stratification. First
Which method? Stratified k-fold.
Yeah.
Okay.
That is for cross validation. For just training and validation, one set we did stratified, sir, so that the accuracy and F1 score are the actual ones and not just random.
Okay.
Okay.
Yeah. That's it from my side. If anyone want to ask any question, they can ask. Yeah. Thank you. Thank you, Atish.
Thank you, sir. Thank you.
I think we can move to the second presentation if nobody has any questions. Right. So I would request Sai Rutvik and Shankha Subra Saha to continue with the next presentation. Please remember, guys, you only have 3 to 4 minutes.
Oh, is my screen visible?
Yes, it's visible.
Yeah, okay. So, good evening, everyone. I'm Ritik, and my teammate Shankha Subra Saha has participated in the track 2 of AML challenge. So I'm in the diploma level. Shankar Subra Saha. I think he's not there. So yeah, coming to the problem statement. Coming to the problem statement, the challenge was to develop a model capable of distinguishing the right, AI generated and human written articles. So what's the importance of this thing? So if I can as a student I can generate any number of prize winning essays, right, using AI tools like ChatGPT. So it would be very important to distinguish between the articles so that ethics are followed, right? Uh, Coming to the dataset exploration and dataset pre-processing and EDA we have done. So you can infer through the plots, right? You can infer through the plots like 400 of them were in from the training dataset were human written, and 100 of them were AI generated. And also you can see through the plot like the number of articles are 40 which are having more than 200 word count, right? So by this you can infer that we have so by this inference we have also we have used pre-processing, right? Text tokenization using BERT tokenizer was done, and also we have ensured padding and truncation, and also we have set the maximum size of the article to 160 so that uniformity in the dataset will be maintained for the training part. uh, Coming to the model selection, we have tried logistic regression and XGBoost and BERT. So uh, the metrics were you can see, right, you can see the performance metrics, right? So the BERT was outperforming the classical ML models, like logistic regression and XGBoost. So why BERT is based on bidirectional encoder representation from transformers, right? So it can understand the context very well. So if you want to if you use the BERT model and determine the cosine similarity between the synonyms, it would give you nearly 1. So it would be like 0.99 and 0.98, right? So the BERT has determined that the synonyms were uh, similar, so it can understand the context pretty well. So we have used the BERT model. So that's the main reason we have used the BERT model. And also it as it was fed on Wikipedia dataset and Media Corpus dataset, it can achieve state of the art performance with less fine tuning, less training, and also compare you can compare, right? BERT has achieved 98.6 accuracy and then a macro F1 score of 96.3, and also the logistic regression has 0.8 80% of accuracy and somewhere around 0.75 F1 score, and XGBoost, right? XGBoost has 0.84 of accuracy. Coming to hyperparameters and tuning process, we have fixed the hyperparameters like learning rate and batch size and epochs to learning rate to 2e to the power minus 5 and batch size to 8 and epochs to 5. So why we have done this? So I have seen that validation losses were increasing beyond 5. So I have stopped the model training and train up to 5 epochs only. The learning rate, the small learning rate ensures that the model will convert slowly. And coming to the tuning part, I have used a learning rate scheduler like step LR to decrease the learning rate gradually. But you can ask that the learning rate schedule is constant, but why? because the epochs were very low, I mean 5, there was no significant change made by the step LR. We have used it, but it didn't make any significant changes. So it was constant. The learning rate was constant. And coming to the training process, I have used the Stratify k-fold process split, where to ensure the model performance was consistent across the subsets of the data sets. So it ensured consistency in the model's performance across the subsets of the data set. So yeah, coming to the data sets, I would say the data sets which were given by the challenge were pretty balanced. If you would see it maintained 75% to 25% ratio, 75 to 25 ratio. So it was pretty balanced. So I didn't make any changes, or there's no special techniques for used to balance the data set. So, but I have monitored the precision, recall, and F1 score so that it doesn't the model is not biased towards any particular class or that. Coming to discussion, overfitting and underfitting, I think I haven't seen any significant overfitting issues by the model. As you know, I have stopped the early till the validation losses were were constant or decreasing. I have trained the model to that only. Techniques used, dropout layer. I have added a dropout layer and learning rate scheduling. Didn't make much of a difference. So that the trainable parameters were like 769. The 768 were outer layer, and the one was inner layer. The middle remaining neurons will be like trained already by the Google, already trained. So yeah, the challenges faced. So coming to challenges, I have directly fine tuning the BERT was so much of challenge for me, and I didn't have any much of a computational resource. So I have used Colab T4 GPU, which is a free tier GPU. So yeah, solutions use dropout and learning rate scheduling.
Sai, could you please
And
hurry it up a little bit?
yeah, the results and comparison with baseline models. BERT achieved 98.6% accuracy and a macro F1 score of 0.963, precision 0.87, mean recall of 1.00. Yeah. Compared to logistic regression, it achieved outperformed very well and achieved state of the art performance. And yeah, a confusion matrix. Yeah, it has our model has predicted 69 out of 77 as human generated, which where 77 were human generated, but it predicted 69 as human generated and 8 as AI generated. And coming to AI generated part, where the articles were of AI generated, it didn't predict that them as human, and AI generated it predicted totally as AI generated, and so that we have achieved a recall of 1.00. Future work and conclusion. I'd like to try out GPT and Robota models and train on the diverse data sets so that and also optimize model performance and deploying the model on GCP AWS. And thank you. Thank you for your attention.
Yeah, okay. Great, Sai. So that's what I wanted to see, confusion matrix you have shown, right? So
Yes.
that's great. Okay, so you have compare BERT and then logistic regression and XGBoost, right?
Yeah, yes, sir.
Now GPT is also there, right? Okay, so you are going, that's the future work, right?
Yeah, yes, sir.
Okay, can you go back to that particular chart where you have compared all these three models? BERT and our that logistic regression. Hmm.
Logistic regression has accuracy of 80% and somewhere around 0.75 as F1 score. XGBoost 0.84 as accuracy and somewhere around 0.8 F1 score. Yeah, sir.
So what parameters we have considered for this regression model?
Sir,
What parameters we have considered this? What parameters we have considered? We have shown some parameters, right? In your slide.
para- could you please
Parameters, I'm saying. What parameters you have focused on?
so hyperparameters I have focused on this epochs will are set to 5. Batch size was 8.
Hmm. Yes.
Yes, sir. Epochs were
Hyperparameters.
set. Yes, sir. Coming to tuning process, it didn't make any much of a difference, this learning rate scheduler in our model. So
How did you select this learning rate?
it's very random, sir. Uh, uh, I've tested for 1 to the power minus 5.
Hmm.
It didn't perform very well, so I decrease.
Okay, so trial and error method, right?
Yes, sir.
Right. Okay. Okay. Yeah. That's great, Sai. Yeah. Thank you. That's it from my side.
Thank you, sir.
Yeah, I guess we can move on to next
Okay, so basically
participant.
next we have
Gautam?
Darshan here.
I'm audible?
Yeah, you can, so the previous one can
Is my
stop.
screen visible?
Just a minute.
Sai, could you stop sharing?
Sai, could you stop sharing your screen, please? Okay, fine, I've stopped it.
First of
Darshan, you
all,
can start.
First of all, good evening, everybody. I am Darshan. I am from foundational level. Although I have 6 months of experience in ML, and I'm a solo participant. Coming to the problem statement, I have chosen for track 2, which is AI-generated text detection in articles. I have used ensemble methodology, which is similar to a random forest, where a random forest uses multiple decision trees to make a end end prediction, but I have used here multiple base models to predict the final prediction. Coming to the objectives, every ML model has 2 objectives. First one is to achieve high accuracy in classification, ensuring the model can consistently and correctly identify the sources of the content. And another objective is to generalize as much as possible, because if you get any data distribution, if the input data distribution is changed, it will affect the model input and it will affect the model output. So I focus on these 2 things: maintaining high accuracy and robustness. Coming to the data sources, I have not only used the data sources which was provided by the team, but I also included the additional data from the Kaggle. And for the because a user cannot use only single LLM for their answer. If you use single LLM, if we train the model with a single LLM answers, it may not predict very well. So I have used multiple LLMs outputs and multiple human written essays. And base models I have used here are BERT, DeBorta, Albert, Electra, GPT-2, and Distilbert. I will give an overview of this in previous future slide. What is an ensemble methodology? I will explain in next slide. Here, whenever I receive a text, first it will be pre-processed. After that, it will be sent to the tokenizer. Tokenizer tokenize the input into embeddings. Here, I have chosen six models. Each model will return the probabilities of the correctness of the answer. I've taken all the probabilities and I um, I have done the weighted average of the probabilities. And also I applied the sigmoid normalization because the probabilities are range from -4 to 4. It will not be sufficient. It will not good if I applied threshold. So I first converted the probabilities into 0 to 1, and then I applied the threshold value of 0.5, and again I get the final output as a labels. Yeah, here I have mentioned. Okay. The technical details, I use PyTorch as my framework for building and training the models, and Hugging Face Hub for loading the pre-trained models. For computation, I relied on Kaggle environment, and I utilized for data manipulation purpose. I used NumPy and Pandas, while regular expressions analytica used for pre-processing the data. The challenges I have faced here is I have limited time because I am a solo participant. I don't have teammates, so limited time for experimenting with different type of parameters like FOX and context size or learning rates. Because and also I have many models, like 6 models I have chosen. Data collection, I have gathered as much as data possible, but that I think it wasn't enough time to collect and create a ideal data set. Computational constraint, I have used GPU P10, which is Kaggle provides a 30 hours free GPU. I have used it, but the computation constant is more because I have nearly 40K of data samples. So computation constant also one of the biggest challenge here. Yeah. When it comes to results, my each individual model gives the accuracy of 96 above, and my ensemble outperformed individual models, achieving 99.9 accuracy on the validation dataset. Validation dataset is nearly, I think, 7K validation, 7K samples of validation dataset. And test dataset, it gives 98.3 accuracy, and macro F1 score is 0.951, which demonstrates its effectiveness in analyzing diversified data. I mainly I mainly focus on bias because a single model can, if I try to overfit the model, although it want to show me it is like overfitting, but it will be overfit. So I use multiple models. If one model make a mistake, another model will rectify it. So I use the ensemble methodology to minimize the bias, ensuring the fair and unbiased outcomes across the different users. Stability. As I mentioned earlier, why I collected the more data. Here, the stability purpose. If anyone uses advanced LLM for generating answers, if we try to give it to the model, it may predict human return. So I used multiple LLMs output and AFS. Yeah, this is about key insights are importance of methodology. I learned about ensemble methodology on other base models, and I tried to balance between the generalization and accuracy also. Yeah, if you have any questions, I'm open.
Yeah, hi Darshan. Yeah,
Yes.
that's great to see. Your approach is pretty good. So you are foundation level student, right?
Yeah, sir. Foundation, although I'm a self learner from past 6 months.
You are working professional.
No, no, sir. No, sir. I'm
Okay.
college student.
Okay. Can you go back to that your result slides?
Yes, sir.
So your accuracy is 99.9% on validation data.
Yes, sir. Validation.
Okay. How did you split data into validation data?
Sir, actually, first I splitted the data, main data, which is 50K samples of data into two data sets. That is
Mhm.
train and test. Again, I
Mhm.
splitted the train data set into train data sets, and for model, I used the base model. So I created the test data sets again. While training, if we are training the model, we need to know how model performs. So I used the validation data sets for that. And in the first split, I have made test data set. That one I have used as a validation.
Okay, and you said your model is overfitted, right?
No, sir, I am not saying overfitted. But if you use single model and train, if you train more epochs, like if we are, my model is not overfitted, but I think if if let's say the model make error,
Mhm.
I want to control that. So that's why I use different models. If one model make mistakes, another model will rectify it.
Okay, yeah, got it. Yeah, thanks, Darshan. Yeah, that's it from my side. Yeah,
Thank you, sir.
great work. Yeah.
All right. Next we have Saminathan, Vanchit, and Sahish Naram. You can begin. Yeah, you're audible.
Yes, start sharing.
Vanchit, you can start.
Could we do next? I'm not sure why, but I'm facing some technical issue.
Okay, then we can proceed with the next team, I believe, right, Gautam?
Yeah,
Yes.
I'll do it after the next team.
Yeah.
Yeah,
Gaurav?
thank you.
Yeah, next we have Gaurav Singh and Sakshi.
Yeah,
Yeah, please,
You
like,
can
start your
begin,
presentation.
Gaurav.
sure. Give us 1 second, we'll
Please,
present
like,
the
try to
PPT.
like make it a bit fast since the time.
Yeah, sure.
Yeah.
Sakshi,
Yes. Yeah, so is my screen visible?
yeah, it's visible.
So yeah. Good morning, honorable judges and everyone present here. I am Sakshi and I'm from the diploma level. I'm currently just started with machine learning with the course Machine Learning Foundation along with Gaurav.
So hi judges and hi everyone. I'm Gaurav Singh, currently at the diploma level. I have completed courses like MLF, MLT, and MLP. Yeah, so we'll start with our presentation today on track 2. Sakshi.
Yes. So this is the solution pipeline we'll be navigating through, which includes the problem statement, data set description, data pre-processing, exploratory data analysis, the training process, hyperparameters tuning, handling the imbalanced data sets, model selection, results, and then the challenges. So this was our problem statement. We were given the statement was to distinguish between AI generated text and human generated text, right? So this has real world application in various fields like content moderation, authorship verification. We were given the data set and we had to develop a machine learning model that could accurately classify these unseen texts into 2 categories. The data set consisted of 500 rows and 3 columns, namely the ID, the text, and the label. So the text was the main content which was to be analyzed, and the AI generated text was to be given label 1, and the human written was given label 0. The data pre-processing.
So we then proceeded to the data pre-processing step where we use the NLTK library to clean the data set. Clean your data set meaning we remove the punctuation and converted the text into lowercase. We then proceeded to the tokenization, which simply means that we'll be splitting the text into individual words, which are also known as tokens. And then the stop words removal, which removes the common English words that won't add any significant meaning to the model. Examples such as I, is, are, etc. And here we have also example. So yeah, now we proceeded to the exploratory data analysis part. So we see the difference between the word clouds of the AI generated text and the human generated text, which differ a lot. So word clouds is basically the frequency of the words. And then we saw the text length distribution in the AI generated and human generated, and the POS tag, which is part of speech tag distribution in AI and human. Yeah. Actually. And then we plotted the box plot to understand the article lengths by label and also do outlier detection, and saw that AI generated text had more number of words as compared to human written. Then we saw the bigram and trigram analysis for all the text combining the human and AI generated, and the distribution of labels, most of which had human written and AI generated was in the minority sample, which meant we had to either oversample or make it the loss function in such a way that it understands the minority plus.
So the human written text has varied lengths and a natural structure, which is with high creativity and abstract thinking and unique ideas. Whereas AI written text lacks deep understanding, is less creative, and it relies on patterns. The training process included, like first we had the data split into 80% training data and 20% testing data. Then we applied SMART to balance the classes in the training data and used Robertra as a tokenizer to pre-process the text data into a format which is suitable for the model. Created data loader objects to efficiently handle the training and testing data sets during the training process. And these are the hyperparameters. We had learning rate, which is the step size of each iteration while moving towards the minimum of a loss function, the batch size, the number of training examples utilized in one iteration, number of epochs, which is the number of complete passes through the training set, warm-up steps, number of steps for learning rate to increase from 0 to its maximum value, the weight decay, which is a regularization technique to prevent overfitting by penalizing the large weights. And this is the search space which we have defined, which includes learning rate, batch size, number of epochs, and the warm-up steps, as I mentioned earlier.
Then we proceeded to building models. We started with our baseline models, that is random forest, which is a simple ensemble learning method that constructs multiple decision trees and outputs the mode of the class, which has the highest frequency. So it had an accuracy of 0.89 and an F1 score of 0.82. Then we moved on to the simple neural network, which is a neural network with an input hidden and an output layer. So we saw the increase in the accuracy and the F1 score because neural networks are able to understand the nuances in the text data better as compared to the traditional methods. Then we used other BERT models as well, that is ExcelNet and DistilBERT. It actually outperforms the BERT on several NLP tasks by capturing bidirectional context. So we achieved the accuracy of 0.93 with ExcelNet and an F1 score of 0.9 with and an accuracy of 0.9. So and DistilBERT is again an advanced version of BERT, which is in fact faster than whatever we used in our analysis because it requires less computation power, and also it retains most of the BERT's accuracy. And we also again saw the increase in accuracy in F1 score, that is 0.94 and 0.92 respectively. And at last, we use the Roberta model. So it is an optimized version of BERT with more robust pre-training strategies and larger datasets of approximately 160 GB, which were developed by Facebook AI in 2018. So Roberta has improvements over BERT. In simple way, it has more training data and longer sequence, and it takes more time to train the data. which makes it a stronger candidate. And we also use the dynamic masking in the ROBOTA model, and it achieved an accuracy of 0.95 and inference score of 0.93. And this is the architecture on the right side. Yeah, Sakshi, you can.
Yeah. So since the data set was imbalanced, so handling the data set was very an important part of the whole procedure. So we use SMART, as I earlier mentioned, which ensured that the model had more data to learn from the minority class, reducing the bias towards the majority class and improving the overall model performance. And we even calculated the dynamic class weights based on frequency of each class in the training data. These weights were then used in the loss function to make the model penalize more for misclassifying the minority class. Next. Now comparing the results. So the baseline models we used were random forest and simple neural networks, and the advanced models included XNet, Distilbert, and ROBOTA. The evolution matrices were accuracy and F1 score, and we can see in the chart here that random forest had the least accurate Mach 1 score, whereas ROBOTA achieved a Mach 1 score of 0.93, which is the best. So these are the challenges which we faced. Handling imbalanced data, feature representation, like we used ROBOTA tokenizer to capture conceptual information, and model selection and tuning, computational resources. Yeah.
For model selection, also basically for the hyperparameter tuning, we use the Optuna, which is a software framework which defines a space to search hyperparameters and then searches for all the hyperparameters that were defined inside the search space. Yeah. Actually. And this was the conclusion and the future work. So conclusion is that we built a successful model using ROBOTA, which achieved an accuracy score of 0.94 and an F1 score of 0.93, with further enhancements using SMART, class weights, and Optuna tuning. Future work, I mean, we could also involve transformers-based models like GPT-3, which was actually not allowed, but we could have used to enhance more the performance of the model. And we could even utilize ensemble methods to increase robustness and accuracy. And additional strategies could be used like domain adaptation by fine-tuning pre-processing steps to better capture nuances in the text data. Yeah, that's it. Thank you. Thank you.
Yes, thank you.
Thank you.
Yeah, that's great, Sakshi and Gaurav, right?
Yeah, yes, sir.
Yes.
Yeah, so can you present again? Can you go back to your slide where you have shown AI generated is 1, then human is 0, that chart?
So
there was one chart in your slide. AI generated is 0, then human generated is like 1 or 0, like
The
that.
bar chart, right?
Yes, bar chart.
Yeah.
Okay,
yes,
so yeah. So first question is, how did you decide that you need to go for this ROBOTA or Distilbert? Why not the simple BERT one? Why? How did you decide which model you have to use?
Sir, we started with the random forest, the traditional machine learning algorithm, but as we went further, we saw that ROBOTA architecture would be perfect because ROBOTA is again a advanced version of BERT, which is a robust BERT, because what ROBOTA does is use dynamic masking, but in BERT model, it uses simple masking. So what it means
yes,
actually is,
ROBOTA is like bidirectional.
yeah, is again a bidirectional. So in dynamic masking, what happens is that it actually masks some of the tokens in each epoch, while BERT does not. So it makes it more robust while training the data set itself. So that's why we thought ROBOTA architecture would be more better as compared to BERT or any other.
Okay, so you have selected based on your own research, right?
Yeah, and we also use the techniques in the performance matrix, that is precision, recall, F1 score, and accuracy. So,
Okay. Yeah, great. Yeah, that's it from my side. Yeah. Thanks, Gaurav. Thanks, Sakshi. Great presentation.
thank you so much, sir.
Thank you, sir.
All right. Next we have Vanchit. Are you able to speak now?
Yes. Can you hear me?
So we have Vanshit, Swaminathan, and Sahishnuram. Just a quick reminder to everyone, please ensure your presentation comes under 5 minutes. We have other
Okay,
teams as
sure.
well, so just ensure you can finish it quickly.
Sure, sure.
Alright.
So good evening, judges and members. I'm Vanshit with my team, Saishwaram and Swaminathan. I am from Diploma right now. Recently finished my foundation, and I didn't learn any MLP or courses now. So we have chosen track 2 for our problem statement. To introduce the track 2, now in recent days with the rapid advancement of AI, there has been a lot of difficulties to distinguish between any AI generated content and human generated content. So here we try to use the ML and DL models to classify the text as AI or human. So moving on with the data sets, the data set we have used was provided at the challenge. In this, we have 3 attributes. One is for the test ID column. Second is the article column, which contains the original text which is to be classified. And the type column is the labeling of the corresponding article. So moving on with the pre-processings, we used the FTFI module to correct text encoding errors. So FTFI stands for free text correction, free fixed text. So what it does is that when any text is presented, it might contain any UTF-8 or some other encoding characters in it by any errors. So this looks for such characters and removes them, making it a clean text. So the next thing we did was to encode all the AI generated and human written things as 1 and 0. We have just labeled them from text to integers. Easier processing. And also we used cross-validation techniques in which we have divided the data set into training, validation, and testing sets. So apart from just cross-validation, we have also implemented the shuffling method in which we shuffle the testing sets so that the model does not learn anything from the order in which the data sets are presented. So moving on to the model selection, we have tried on models like XGBoost and extra trees. And as you can see, like we have got an accuracy of 0.98 for BERT and macro1 of 97.97. And similarly for XGBoost, it's 0.85 and 0.76. For SVM, it's 0.81 and 0.70. And for extra trees, it is 0.82 and 0.68. So with the training and test splitting done with all the models individually, we have got an accuracy score and score for BERT. So thus with this info, we have concluded to use BERT as our model. So why choose BERT is that, so basically BERT stands for bidirectional, it stands for bidirectional encoder representation for transformers. So it's a deep learning model for natural language understanding, which uses transformer architecture and it's designed to capture context with both. So it uses architecture like transformer architectures, and it contains components like input embeddings, which convert the input tokens into dense vectors. And it also has a self-attention mechanism, which helps it to determine the relevance of each token with relation to each other. So it would help it to understand if it is a AI generated or human written model written text. So moving on with the hyperparameters. So we have used the num labels in the BERT model to 2, as we only have 2 labels, which is AI generated and human. So we have used an Adam optimizer here with a learning rate of 0.00002. So this learning rate was used to ensure that the model learns in a steady rate, so that it could prevent any misclassifications of the text. Since the labels here are 0 and 1, we have used a sparse categorical function for the loss function. And further, we have divided the batch size as 8 and the epochs to 3. This is to ensure that the model learns in a steady state, and the epochs are only to 3 because beyond 3, like we were finding that the accuracy were dropping a little bit. Same goes with the loss also. So before each epoch, we have shuffled the data and batches so that the model doesn't learn which the data were presented, so that we could prevent any possible overfitting or biased learning. So training process. So in the training process, like we split the training set into, we split the data set into 70% training and the remaining 30 as a test data set. In from that 30, we have split the 15 as temporary set for validation and the remaining for testing. So this validation set was to measure the performance of the model at each epoch, so that we could look at how it performs for each epochs. So handling the data imbalance. So we found that the AI-generated text were very less when compared to human-generated text. So to address this imbalance, we used an upsampling method. So here what we did was we duplicated the AI-generated AI-classified text and then appended it with the data. So this duplication of samples helps us to increase the representation of the data set and also helps the model to recognize patterns in AI-generated text more effectively. So one particular challenge that comes when we use upsampling is overfitting of the model with respect to the AI-generated text on it. So this was mitigated by using the regularity which is inherent in the BERT model. So finally, coming to the results, as we saw earlier, like the BERT model gave us a high accuracy and FN score with the training data set. And when we implemented it with the test data set, we got an accuracy of 0.969 and a macro FN score of 0.922. And comparing with it with the baseline models of like XGBoost, XtraTrees, and SG, like said, as mentioned earlier, the BERT model has outperformed the baseline models both in accuracy and FN scores with its transformer-based architectures for this task. So the challenges that we faced were, since BERT is a deep learning model and it requires significant computational powers and time to process all the data. And we had a lot of metrics like accuracy, macro FN score, AOC, ROC curves, and its areas. So like some models, though it had high accuracy, but they were conflicting with macro FN score. So we were facing it, finding it difficult to choose the model. So our future works include that like we are planning to transform this into a web extension, making it accessible to a broader audience. So this will enable them to classify the text in real time and would have practical applications in detecting AI-generated context and education. So actually, we have included in this model is that we have a feature which takes the input as a PDF and then would generate a copy of this PDF highlighting the AI-generated text. So more about this topic will be continued by my teammate.
Hello, am I audible?
Yes.
Yeah, okay, thank you. Since this task was interesting and challenging, we took a step further and added an extra feature in this task. That is, the input is a PDF. I mean, we can give a PDF as an input, and we can get the same PDF as an output. But the difference is that we can able to classify all the AI-written text in the PDF, and we can highlight it so that the output PDF will have the highlighted AI-written text in it. So as a sample output, the right side in the screen is a sample output which has highlighted text in it. It is a single page in the PDF, so which has highlighted text in it. So for this, we used FITS module in the Python. So Fitz model is used for parsing and manipulating the contents in PDF. So we used this model for extracting the text in the PDF, and we used the pre-trained model BERT for classification, and we highlighted the text in the PDF. So the output PDF will have the AI generated text in it, highlighted in it. So as a future scope, we are planning it to make it as a web extension, so that if a user opens a PDF, he or she might be able to see what all the AI written text in it. So this was a future scope for our project, and we are planning to make it. Then thank you for this task. Yeah, that's all.
Thank you.
Yeah, thanks Swaminathan, thanks Sanjit, great presentation. So just one
Thank you,
question.
sir.
So you said in PDF, if I upload the PDF, I will get to know how much is AI generated, right? So do you put
Yes.
any threshold value for character limit for checking the characters? Because if I say just simple one sentence, that it is difficult to predict that it's AI generated or human written, right? Do you have any threshold value for character limit?
No, sir. We doesn't have any character limit in the PDF, so that the PDF can contain any number of characters in it, and our model will be able to classify it. I mean, if the text is AI generated, then it will be highlighted, or else it will be the same PDF will come as an output.
Okay, so what if I have 3 paragraphs, and out of 3 paragraphs, only one sentence it is highlighted as AI generated? So can you tell me whether that particular model is accurate or not?
Yeah, that's the thing that we faced in our earlier making of the model. Then we increase the epochs so that the model can be able to classify it effectively. Then I mean, the same problem you said, while I'm coding, I face the same issue, so that I gave 20 pages PDF, but only 2 paragraphs in it was came as AI generated text. So to solve this, we increase the number of epochs. That was the only thing that I did. But in the next while I'm trying the next time, the 20 from the 20 pages, it showed me like 4 pages was written by AI.
Okay. So you are saying if you increase the epoch, you find better accuracy, right?
Yeah. That's what. Yeah, I mean, for as an initial step, I raised the epoch to see the output, how it comes. But then I also asked ChatGPT, and I also asked the AI detector, which was in website, that these are the sentences that was written by AI or not. The same website gave the same answer, that these were all the sentences which was written by AI. So we concluded that, yeah.
Okay, yeah, great. Thanks, Swaminathan. Yeah, thanks, Sanjit.
Yeah, thanks.
Thank you.
Am I audible?
Yes. Okay. Proceed.
Just a second. Is my screen visible?
Yes, and please be fast. Please try to complete it within 3 minutes, else like we won't be able to finish.
Yes. A very, very good evening to everybody present in this Zoom meet and watching live on YouTube. Today, I, Ayan Qureshi from the foundational level of the IITM Online BS degree, will be presenting to you our solution on the challenge of detecting AI-generated articles. My team consists of myself and Mr. Nikhil Maurya. Now, in this challenge, we were expected to make an AI model which could detect if an article was AI generated or not. We were also asked to explore the capabilities of ML models to accurately predict the origin of textual content. Now, while trying to figure out how to choose my model, I had one condition, that it had to be used with PyTorch, because I have some prior experience working with PyTorch. So while trying to look for solutions on the internet, I got 2 solutions which I could use. One was to use NLTK, or Natural Language Toolkit, and with PyTorch, and another was to use XLM Roberta model. I used both of them, and now I'll be sharing the procedure and the results of the 2 with all of you. For both the models, I got the dataset as a data frame using the read CSV command, and did the following. For the NLTK plus PyTorch model, after splitting the dataset, I needed to remove any unnecessary words, such as any repeating words that would keep on occurring, or any symbols. So I used the Porter Stemmer command to clean the article. After the removal of such words, I use the scikit-learn's extract feature command to extract the text features from the dataset. After that, it was all up to the PyTorch model that I built. For the XLM Roberta model, after getting the data frame, I first had to convert the data set to lists so that it would become an iterable. After converting them to iterables, I converted them to iterable wrappers and then mapped the transformation function, which was provided by PyTorch and is based on sentence-piece tokenization. After that, it was all up to the XLMR model. Before seeing the accuracy of the functions, first I would like to talk about the hyperparameters. Hyperparameters are basically any parameters of an AI model that we can change. Examples are learning rate or choice of optimizer. In my NLTK plus PyTorch approach, I use the Adam optimizer with log softmax activation function, and the loss function was NLL loss. And setting epochs to 30 and learning rate to 0.0001 gave me around 70 to 80% accuracy on the validation data set. But after I tested on the test data set, it gave me a MAC F1 score of 46%. So I thought I had to change my strategy and use XLM Roberta model. On the XLM Roberta model, I left mostly all of the hyperparameters to default as they were giving the best accuracy. I only tested changing the learning rate and epochs. I increased the learning rate, but it did not improve the model. So after changing the learning rate, I increased the number of epochs to 5, and that increased the accuracy to about around 90% on the validation data set. Here, as you can see, the NLTK plus approach model, the loss goes down, but the accuracy stalls after reaching around 80%. And for the XLMR plus PyTorch approach model, you can see that the loss is going down and the accuracy reaches about 97%. And now for the challenges that I faced for the NLTK plus PyTorch, the model did not reach accuracy above 80%. I tried changing the loss function, the activation function, the learning rate, the number of epochs, but it stayed the same. And using my on my XLMR plus PyTorch model, the challenge that I faced was that due to me not being assigned a GPU on Colab, the model trained very slowly on CPU and would crash frequently. And since the Torch text library, which is not supported by CUDA 12.x versions, and the code which would not run when I tried to run it locally. Also, the Torch text library is being deprecated and it would no longer be updated by PyTorch. And that is it. Thank you for giving me your precious time and for the opportunity to learn so much about text classification. I hope to keep learning more and more about a variety of topics under machine learning. Thank you.
Okay, yeah, that's great, Ayan. So only like, are you only working on this, or your teammate is also there?
He was there, but he could not attend this meet.
Okay. Yeah. So yeah, I appreciate your honesty. You have mentioned in the slides. That's great to see. Yeah. So yeah, no question from my side. Yeah, that is pretty much clear. Thanks, Ayan.
Thank you, sir.
Yeah, so next we go with like Siddharth. I hope you are aware about the time limit, right? Please like proceed.
Yeah, so good evening, everyone. Myself, Siddharth. I'm currently in the diploma in programming level, and I am not a machine learning student. Basically, I'm not practicing MLP or MLT, and I've done this project alongside with my teammates Sarfaraz.
Okay, so good evening, everyone. This is Sarfraz Ahmed. I am a diploma for data science student, and currently I'm enrolled in MLP project.
Yeah, so we were allotted the track 2, which was differentiating between human and AI text. And so let's take you through the journey. So we started firstly with studying the data, then we moved on to the pre-processing part, and then we headed towards the training the model, wherein we used many models like rainforest, random forest, then logistic model and ensemble. And also we head on to hyperparameter tuning and then upgrading a BERT model. So first of all, when we analyze the data, we figured out that the data is highly imbalanced. Clearly, the human-generated one was in majority, while the AI one was in minority. So then the first idea that came to our mind was, first of all, doing pre-processing and vectorization. So then we use some functions like tokenizing, stop words, and stemming, which helps us to remove some common words like either, ism, type words. And then we tokenized to turn long sentences into short text, and then we use stemming to convert the words into their root form like eating to eat. And then we vectorized our text using the TF-IDF vectorizer. And then we moved on with our first model, which was random forest alongside smooth. So basically, Smooth helps to handle the imbalance in the data. So we thought it would be a good idea to go ahead with Smooth. So this model gave us an accuracy of 0.89 and F1 score of 0.81. So then we thought we should maybe try another one. So we went ahead with the logistic regression model again alongside Smooth. And this one gave us an accuracy of 0.85 and a MAC F1 of 0.76. So we thought maybe if we combine them, we could get something. So we built an ensemble model which gave us an accuracy of 0.86 and MAC of 0.71. In this model, we had combined the random forest, SVM, and the logistic one. And then we moved ahead with the hypertuning part.
Okay, so not sticking to the default parameters. So here the hyperparameter tuning comes to the picture. So for doing this, we use the grids of CV, which is a tool by Sklearn library, and basically we assign several parameters so that it can make several combinations, and for the random forest classifier, and then we use the best parameter function so that I can get the best parameter. We fitted the model with these best parameters, and here's what we can say. Very cool, like very nice numbers came into the evaluation metrics. But not sticking to this, let's try this idea to the logistic model also. So the same thing we did here, like we assigned the C values, different values of C, the penalty L1, L2 for regression, elasticness, basically the combination of both L1 and L2, and several parameters like that. So we got the best parameters and assigned that parameters and trained the model. So here also the same thing happened. The accuracy went up and macro average F1 score also went up. So basically the conclusion is like hyperparameter tuning went well for us, but not sticking to here. We were very much curious. So here where the BERT model came into picture.
So basically, when we were training our baseline models, we also worked on a BERT model, but it was very underperforming. Like it has the similar accuracy and math similar to the logistic one. So we thought maybe we could upgrade it. So here is a comparison between our initial BERT model and a final BERT model. So in the initial one, we didn't use the evaluation strategy. So it was set to default. So basically, we had eval steps, we converted it to 500. So the model will recheck itself after every 500 steps. And then the learning rate was default in our previous BERT model. So we changed this to 2e minus 5 so that the learning rate can stabilize with the data. And then since we thought that iterations were less, so we increased the iterations from 3 to 5. And then one thing we noticed that maybe the model is overfitting because we weren't getting a nice accuracy with BERT1. So we thought maybe we could use the early stopping callback function. Because with this function, the model will stop training itself if the accuracy starts decreasing, because we have set the metric to accuracy. So whenever the accuracy will stop decreasing, the model will stop training itself. And this helped us a lot. And with this, we reached an validation accuracy of 0.97 and a MAC F1 of 0.96. And while our previous underperforming model had a MAC F1 of 0.81 and an accuracy of 0.84. And our final submission result was something like this. Our final accuracy was 0.95 and our MAC of 0.89. Thank you very much for this presentation. Now, one thing more, I would like to show the deployment of this model because Swamit asked me to deploy this. So I would just deploy it once. So this is the deployment of the logistic one, not the BERT one, because the BERT one takes a bit of time. So I deployed it using the logistic regression model. So if I put any text inside it, it will just predict if it is human generated or AI generated. Like this is something I took from the ChatGPT and it shows AI generated. And if I write something like I am Prabhar, it will something like show like this, like it is human generated. However, it is not very correct because we use the lower model. So yeah, that was it. Thank you very much for this for giving us this opportunity, and it was a great learning experience. Thank you very much.
Thank you so much.
Yeah, great work, Sarfaraz and one more, Siddharth, right?
Yeah, thank you, sir.
Yeah, so you have deployed the model, but while you are testing, you have only put a few characters, right?
Yeah, yes, sir.
So it is difficult to predict whether it is AI generated or human written. So that's what I'm saying. If you want to predict whether the complete paragraph is AI generated, so we should have
Yes, sir.
sufficient number of characters to predict that.
Yeah, so the max length was just 256 only. That's why.
Okay.
Yeah, yes, sir.
Okay, but yeah, great to see this. Yeah, thanks,
Thank you, sir.
Siddharth. That's it from my side. Yeah.
Thank you, sir.
Thank you so much, sir. Thank you.
Right. So up next we have Shiva Kumar.
Hello.
Yes, you're audible. Please.
Yeah,
begin.
yeah, sure. Good evening, everyone. Myself, Shiva Kumar. So this is the presentation regarding that AML challenge. I was in track 2, AI generated text detection in articles. So basically this track tells that we need to develop a model capable of accurately classifying text as human written or AI written. Then next, the dataset was given of 500 rows, which was not correctly balanced. They consist of 386 human written articles and 114 AI generated articles. Based on that data set, I did some pre-processing. So basically in that, I converted the labels to 0 and 1 and performed some text cleaning, like converted everything into lowercase, removed some stop words using analytical libraries, and also eliminated some punctuation and special characters. The pre-processing mostly was done through RE module of Python. Next, model selection. So basically, I use 4 types of model: support vector machine, logistic regression, random forest, and BERT model. Initially, I tried with SVM, logistic regression, random forest, but the accuracy and F1 score was in the 87. Maximum I achieved at 90, because it uses the traditional machine learning models and it relies on feature engineering. So I moved to BERT transformer. Although I was new to it, and so I use BERT transformer, which uses less feature engineering and also provides a better performance on classification tasks. So what is BERT? BERT is a bidirectional encoder representations from transformers. It is developed by Google in 2017. So it is pre-trained on a huge amount of data based on Wikipedia. So BERT has mainly 2 tasks. One is MLM and one is NSP. MLM stands for Machine Master Language Model. It learns to predict missing words in a sentence. And NSP is next sentence prediction, learns to predict whether 2 sentences are related or not. Next, hyperparameters and tuning process. So the training split was simple. I used the sklearn library and it was an 80-20 ratio. So for the BERT training, I used different combinations of parameters, test and trial method. So finally, I got it good score with this parameters. The manual tuning only was done with test and trial error. Based on the validation performances, I being changed the hyperparameters and all. So the challenges was faced was the dataset was imbalanced. It mostly was human written and a bit was only AI generated. And even the Google Colab was giving issues, and also it was challenging to perform in the Google Colab. It was taking time to perform and all. And although I was new to BERT and this machine learning, I also faced some challenges regarding. So the results, as we were to submit 3 sets of challenges, 3 sets. In the set 1, I achieved a validation accuracy of 95, in second of 97, and third of 94. The second was the highest accuracy with 92. Summary, to put it simple, the problem statement was detecting AI generated text in articles. Dataset was 500 rows. So I used a BERT transformer with some regular features, and results, it achieved a good accuracy and also a bit of robust performance. Future works, I would do model improvements, like even fine tuning and adding undersampling methods and also other transformers like Roberta and all. We'll use also different transformers and also some advanced techniques. Thank you. That's
Okay, great, Shiva Kumar. Thanks. Just one question. The data is imbalanced, right? So how did you split the data into validation data and training data?
Sir, the training and test data was split into normal 80-20 ratio using the sklearn library. So what I thought was I'll do normal using that data only in a BERT model or logistic regression, whatever. If I get a heavy difference in accuracy or I get less accuracy, I thought to change that split or do another sampling like that. But it was good only 90, so I didn't perform any undersampling ratios like that.
Okay, yeah, that's fine. Yeah, thanks, sure. Yeah.
Yeah, sure.
Next up, we have Rohit, Satish, and Mohit Kumar.
So yeah, am I audible?
Yes, Rohit, you're audible.
And is my screen presenting as of now?
Yep, it's
Thanks.
It's visible. Yes, you can start.
Yeah. So before I begin, I'd just like to take a moment to actually say that all the organizers and volunteers who worked for this program have done a wonderful job over the last week. So hats off to you guys, and thanks for giving us such an opportunity. So yeah, I'm Rohit. I'm from Palakkad, Kerala, and my teammate Mohit Kumar, he's on this call, I think. Yeah, so Mohit is from Rajasthan. He's currently pursuing his MA, MCA from Pondicherry University. We registered for track 2, the AI generated text detection, and we have somehow half and puffed our way to the finals. So here goes. We'll start with a quick look of the problem statement and the data set before we actually go into the model. So the problem statement was basically about developing a machine learning model which could accurately classify whether a given text was AI generated or written by humans. Now, the data set that was given to us had around 500 rows, out of which 386 were human representative samples and 114 were AI generated samples. And a slide that I've not included here is about pre-processing. Not much of a pre-processing was done, except for the Unicode wrongly encoded characters, which was taken care of by the FTFY Python library. And now moving on to feature engineering. Now, before I talk about feature engineering, I'd just like to say that before we even started modeling, the basic intuition behind our code was that there's a precise and concise manner or semantic structure with which AI generates text. What I mean by that is AI doesn't really just speak words that come to its mind and mouth at the particular time like we humans do. So there's got to be some precise, the precise, concise structure to how it generates data. And that's how we went on to select our features. What our model does at a very high level is it uses DistilBERT to convert the text data into word embeddings, and that's what we have worked with. Now, what's actually DistilBERT? DistilBERT, as the name suggests, is just a distilled version of the BERT transformer from Google. BERT and both BERT and DistilBERT have been designed to recognize the context in which words are used in sentences and then convert them into vectors in space. Now, how's this different from other, IFDF, IDFD, IFDF vectorizers and tokenizers and other stuff, is that BERT and DistilBERT actually recognize the context with which each word is being used. And you could have the same word in two different sentences and still have two different vectors for them because they're being used in different contexts. So that's it about DistilBERT and then word embeddings. That's what we've used. After we had actually done with our word embeddings and DistilBERT, we had actually had around 19,000 features in our dataset. Now that's actually quite a lot. So what did we do? We PCA'd the dataset to around 500 features where maximum variance was achieved, and we worked ahead with that. To handle the class imbalance, what we've done is we've used SMOT, and the graph you see below explains why we took 500 data sets and not something else, because that's where we achieved 95 to 100% variance. We maintain 95 to 100% variance in the data set after the PCA. Now moving on to model selection, and I'm going to be brutally honest here because this is my first rodeo with machine learning model building and all. We didn't really have an idea about how to select models. So what we did was, after we split our data into training and test set, we actually ran almost all the classifiers we could get our hands on. And I just listed 3 of them. The 3 main ones we worked with: random forests, logistic regression, and support vector machines. I'll talk first about random forests and support vector machines because those 2 were the ones we didn't take. Those 2 worked really well with the non-PCA dataset. But when we PCA'd the dataset, the results were really poor. And I think the reason for that might have been that when you PCA a dataset, you lose most of its non-linearity and a lot of the variance in the data. And that's, I think, one of the reasons why the main model, the model that we took, logistic regression, actually really worked. Worked really well. And so yeah, that's the model we went with. And for model evaluation, we used accuracy, precision, recall, and inference score, the classification report, and cross-validation we did. And what we found was that logistic regression worked really well on the PCA dataset, but really poor on the non-PCA dataset. And for the other 2 models, it was really the opposite. Now, why we took logistic regression was because of the time complexity factor. Because we had 19,000 data set, 19,000 features in the non-PCA data set, it took a long time for all 3 models to actually complete the evaluation. And logistic regression was just, as you can see from the cross-validation scores, really consistent over all the, was really consistent. And that's why we took it. Going on to challenges, I think as a newbie to machine learning, everything was a challenge over the last weekend. And these 3 just are the most deserving ones. So yeah, I think that's it from my side. Thank you.
Yeah, thanks to it. Great work. So, yeah, you observe what challenges you have faced for this particular thing, right?
Yes,
So that's a learning part for you, right? So great to see you have mentioned that. Yeah, so I don't have any question to ask. So that's it.
Yeah, thank you, sir.
Thank you, Rohit.
Right. Next up, we have Shravan K and Stuti Baguna.
Shambhavi, I don't think that they are like present in the meet. I think we can go with the next one.
Okay. So next up, we have Arka Das and Nimesh Sinde.
Okay. Arko, can you please like start?
Guys, are you present in the meet?
No, I think they are informed that
They aren't informed.
Okay, fine.
They aren't present.
No worries.
Okay, so we should go with the next one.
Yeah.
Manasmita
Okay.
and
Yeah, Devopriyo
Devopriyo.
Saha. Yeah.
You can
Yeah,
start.
hi. So, hello, good evening, everyone. So, I have completed BSc degree, and Manasita, my teammate, is in BS level. So, our challenge was related to track 2, which is AI generated text detection in articles. So, let's talk about the problem statement. With the rapid advancement of AI, it is very much necessary to understand the distinguishing factor between the human written and the AI generated content. So main objective was to build a robust ML model to detect AI generated text. Coming to the dataset overview, it contained 500 samples with 386 human written samples and 114 AI generated. And we had around 517 samples for the test data. So pretty much we can understand that it was an imbalanced data set with more biasness with the human written content. Next, moving on to the feature engineering, I did an extensive feature text pre-processing techniques using multiple libraries, which included RE, NLTK, and all. So first of all, I removed the URLs, and then there was a text encoding and decoding factor that I used to correct the characters. And I removed the non-ASCII characters if it was present, and I removed punctuations, converted to lowercase, tokenize each of the sentence, remove stop words, and use lemmatization. Along with that, I tried to understand whether there are certain features that can be added to distinguish this human written text and AI generated text. So I came up with these three feature extracted features that I have added. First one is average sentence length. Second one is type token ratio. So where we can see how many tokens were unique out of the total, and the count of parts of speech tags. So these were the extra features that I have used along with the original text. So main transformation that I have used is TF-IDF vectorizers, which transforms the entire text into tokens, and we get numbers for each of the text. And I have used standard scaler for all the scaling the entire data set. So coming to the model training part, normal train and test split were used, which is 80% train and 20% test. So out of that, I have tested on the 20% data at first run. And then while predicting, I have used the entire training set for final evaluation. So I have also used randomized search CV and cross validation for hyperparameter tuning for the multiple models that were used. To handle the imbalanced data set, I have utilized the class weight. I didn't go for SMOT because I thought of it being generating some random or garbage values. So I went on with adding the class weight. So basic simple machine learning models were used, starting from logistic regression, SGD, linear SVC, random forest, and moved on to the ensemble where it started from random forest, XGB, and light GBM. And finally, utilize the voting classifier with a hard voting strategy to come up with the final result. So this slide tells you about the test data performance on the basic ML models. And on the left-hand side, this is pretty much tells that the XGB and the light GBM models were giving higher F1 score. This is with respect to the normal parameters without any tuning. And on the right hand side, we got again for the voting one 0.91 as the F1 score. XGB was pretty much on a similar line. So yes, so this is the confusion metric that I got from the validation set, having around 91 F1 score, wherein human written text was rightly classified, and AI there was some misclassifications which we are trying to maximize, and hence I think the recall of AI generated text should be high, being on the front side to detect the AI generation. So that is the main motto of this piece. So there was more window to do this. That can be done using advanced LLM models. And yes, while training phase, I also encountered the overfitting piece because the samples were less. So overfitting was there. Yeah, right. So regarding the challenges, training samples were limited and there was class imbalance. With respect to future work and conclusion, I have obtained an F1 score of around 69.7% with an accuracy of 80.5. So for future work, I would be using some advanced techniques with respect to large language model, the pre-trained transformers to achieve better results, and finally deploy the model for larger audience. Yes. So thank you. That was the entire project all about.
Okay, yeah, that's great. Good to hear. So just one thing, like most of them have used BERT model, so why don't you use that?
Yeah, I thought that GPT was not allowed, so I mean, I assume that I cannot use pre-trained transfer or something like that. So that's why I used only the normal classical ML models.
Yeah, this is also great. Yeah, yeah, thanks, Devapriya. That's it.
Right.
Thank you.
Thank you. I think next we have Karthik Agarwal. Are you ready to present?
Yes.
Yeah,
Yeah.
and so like with this, we start the track one. presentations. There is a fake news detection in the Dravidian languages. Yeah, you can begin.
Should I start?
Yes, you can begin.
Okay, thank you. Good evening, everyone. Good evening, sir. Good evening, ma'am. I'm thrilled to be here. I'm Karthik Agrawal, currently in the diploma level. I'm in my first term of the diploma level. I've taken up MLT, MLF, BDM, and TDS this term. And I was really excited to be part of this competition because literally everything about natural language processing that I know today I owe it to this challenge. And let's begin. Let's get on with it. Looking at the problem statement, it was quite straightforward. We were supposed to come up with a multi-class classification model that could classify Malayalam news between 5 classes. What are the 5 classes and what did the data set look like? We'll come to it in just a moment. The main challenge that I personally faced, and I'm sure everyone would have, was that the data set given to us was extremely heavily imbalanced and skewed towards one category, which was very difficult to come by. Looking at the training data set, here are the 5 categories into which the news headlines and comments were classified into, were labeled as false, partly false, mostly false, half true, and mostly true. This is not the representation of class distribution, which is very different. This is only the representation of the 5 different classes that were given to us. And moving on to the class distribution, by the looks of it, we can see that the data set is heavily skewed towards the one category. And this is a single data entry for one of those categories, namely mostly true. We cannot even see the bar chart for that category. It's not visible. So coming up to the choice of model, the next question was which model to choose. Being new to all of this, I was exploring all the multi-class classification models, and I came across a sea of models. There were the transformers, BERT and GPT. There were the traditional classification algorithms, and there were some deep learning algorithms completely out of my reach. So I went ahead with the transformers primarily because fake news required some contextual understanding. So the model should be able to understand where that news is coming from, not only just in relation to that sentence or relation to that provided prompt, but also in a wider context. What does the news mean, and how does it relate, and how likely is it to be true or not? So therefore, I chose the transformers for these 3 reasons: contextual understanding, self-attention, which should be able to rank the importance of each word and each token, and transfer learning. Obviously, it should be pre-trained and should already have an understanding of how the world works and how news works. And so the top contenders in transformers were GPT and BERT. BERT usually dominates the text classification field, and as seen by all the presentations before me, it's the king of classifiers, and usually people would go with that. But I chose GPT instead to go completely with GPT, just because I felt that it would generalize better, because GPTs and particularly top frontier models, these days they are pre-trained with huge amounts of data and have a massive understanding of news already. So I believe that I would be able to take advantage of their ability to generalize well with fewer amount of fine-tuning data. So the model that I went ahead with was GPT-4o Mini, which is the latest and the most economical model released by OpenAI. And I proceeded with data augmentation, which is where we started with an imbalanced data set. So I explored techniques and ideas where we could build on our imbalanced data set and try to balance it somehow. The techniques that I explored are as follows. The ones that I went with were back translation and data duplication. I avoided text generation, self-training on all of those because they were they were against the competition rules. We were not allowed to use any external data. So I'll just quickly give an overview of how I performed back translation. It was a simple Google Sheet function. Basically, I converted Malayalam text into one of the many languages. For example, in this particular example, ML means Malayalam. TH stands for Thai, which is the language of Thailand. And I converted this text back from Thai to Malayalam. And this created a variation in the dataset, some variation in the dataset. When I checked for duplicates in the Malayalam text, there were fewer duplicates. So definitely there was some variation created in the dataset. And I was also, and then I obviously went ahead with data duplication, created duplicate entries of some classes to increase their quantum, increase their quantity. And here are the results, pre and post data augmentation. As we already saw, the original data set was heavily skewed towards the original, towards one of the category, which is the false category. But the augmented data set could seem to be leveling off somewhat and could be seen to be a little balanced. Then came the split. So because the distribution was such that there was a skewed distribution, the split was accordingly stratified for each class, and I made sure that the test and validation splits had the same representation as my augmented training data set. After that, because fine-tuning GPT requires the file format to be in JSON, also JSON-L line by line. So first it got UTF, should be UTF over here, UTF encoded into the following format as per Malayalam encoding. And then the CSV was converted into JSON-L for training. So this is how a sample training, one entry of the training data set looked like, containing of the system prompt, the news, which is encoded as follows, and the label for it. I use OpenAI's platform to optimize all the hyperparameters. They have their own algorithms. I believe they use learning rate schedulers and grid searches to optimize for their hyperparameters. Although a couple of, for example, epoch is selected by me, and this was the statistics during the training process. It came up to be 1.7 million tokens for the training data. Took 2 epochs, 13 batch size, 1.8 multiplier, and a very low training loss. This at first seemed very scary to me, for any model to have such a low training loss, and comparatively higher validation loss is scary. But because this was GPT and my data set was nothing compared to what it had already been trained on, I went ahead with it and tried my test data and my validation data. Didn't seem very promising at first, but this, upon further work on it, I could see that this is the best I could come up with. Internal metrics had the scores of 0.661 F1 score and 82% accuracy, which is not impressive at first sight, but given the difficulty of the problem, is the best I could work with. And finally, the test, the challenge scores were as follows for the first and the second test, and the third test as well, with an F1 score of 419 and an accuracy of 76.5, 0.765. And that's how I would like to conclude my presentation. Thank you.
Karthik, great presentation.
Thank you, sir.
That's like all the points you have covered in the slides only. So, but why you have taken Malayalam to Thai language?
Sir, I've taken 17 languages. That one was just an representation of how I performed back
Okay.
translation. I've taken all Asian languages. I've taken one African also, and Indian languages also, Gujarati, Tamil, Telugu.
Okay. So this model will work when the input is in all Malayalam, or if I just use Malayalam plus English, in that case, what will happen?
So it works because okay, I don't have that sample with me, but when I was prompting the model to get my data, I had put in that the following is the news headline in English, and then the news headline was in Malayalam. So there was no trouble. The model had no trouble processing both languages.
Okay. Yeah. Yeah, that's fine. Thanks, Karthik. Yeah, great work.
Thank you, sir.
So I think
Right.
that also like Karthik has like mentioned that external data like can't be used, right? Did you like mention that?
No, do you mean JSON data?
External
External,
data
external.
can
Yeah,
be
yeah, external.
used in the first actually the track, okay? And external
Correct,
data
correct.
can't be used in the second track.
Sec
That is the
oh,
I1, okay? In this
oh, okay.
you had to use, you will basically could have used external data as well.
Oh,
As
oh,
well,
all
so-
right, okay.
So
all
like
right.
that's like miscommunication from your side. Fine, yeah.
Gotcha.
Yeah, like Shamil, we can proceed.
Yeah. Okay, guys. Up next, we have Sheikh Gufran Jabbar and Sukanya S. Are you ready with your presentation, people?
Yes, ma'am. Am I audible?
Yeah. Yes, yes, you're audible.
Okay,
Please continue.
Yes, yes. Let me share my screen. Is it visible?
Yes, yes, it's
Hello?
visible.
Okay. So my name is Sheikh Gufran Jabbar, and I recently completed my diploma in data science in Jan term. And I have one teammate. Her name is Sukanya, and she is doing diploma in data science, and she will about to complete his diploma. She is not here because she is out of town for some work. So I
think
will
she's
handle this.
present. Sorry to interrupt. I think like she's present in the session. Can you check?
But she is in crowded area.
Okay,
She
fine.
won't be able to talk.
Fine,
So
fine.
I will handle whole presentation. Okay. So let's start with the problem statement. So in this challenge, we took track one,
Just to
which
interrupt,
was about.
Gufran, I think you haven't like shared your screen. Can you check?
Is it not visible?
Gautam, can you just confirm?
No, it's not visible. Your
Not
voice is
visible. Yeah.
not your screen.
I'm using a mobile. That's why.
Can you please like try it like once more and just like let us know? Okay, fine, it's fine. Yeah.
Yeah, now it's fine.
Okay.
Proceed, please.
Okay, okay. Okay. So let's start with the introduction. So we took track one from this challenge, which was about fake news detection in Dravidian languages. So language which is given to us is Malayalam. So in this challenge, we have to categorize the given comment or news in 5 distinct categories, which is given as false, mostly true, partly false, and mostly false, and half true. So generally we follow these steps in machine learning context. So as you can see, learn from the data, see data, and then do feature engineering, then model training, and evaluate our model on the evaluation set. So next to the some our codes and logics. So here is the some description about our data set. So here we can see that there were two null values out of 1537. So we just dropped them and reduce our data set to 1535 samples. So in this data set, we have so much imbalance. We had news of false category 11 to 1128, and there was only one case of mostly true, and there were 38 samples of partly false. So that was a very high imbalance data set. So there is a so we must have to use some resampling method to balance our data set. So my teammate Sukanya, she used random over data sampling method from IMB Learn library. So she created some sample news equally to belong each category. And in this process, we used TF-IDF vectorizer for vectorizer purpose. So let's go to the model selection process. So when we get data, so we have to decide which model we have to choose. So this problem was multi-class classification problem. So we got some classification algorithm. So in this problem, for this problem statement, we use BERT model, MLP classifier, logistic regression, and multinomial NB, random forest classifier, and RWS classifier. Actually, in this out of 6 models, I trained only BERT model, and remaining 5 models, Sukanya worked on all these 5 models. After that, these are some results from our 6 models. So as we can see that BERT model had a 0.72 accuracy on validation dataset, and a very low F1 score only for false dataset, false comments. So, and as you can see that for other models, different accuracies and F1 scores. So we concluded that for this challenge, we will make submission using MLP classifier and a random forest classifier. So because their accuracy and F1 score were good. After that, that's it from our side, but we included some points where could be improved in our in this challenge. So these 2 things we found out majorly were missing from our side. That was a visualization. So we did not use any visualization technique or method to visualize our data, and we didn't use hyperparameter tuning in this our process. So these are 2 I thought personally that could be improved for a better model to achieve more accuracy and F1 score. So thanks to the organizer and all the Venan House secretary and all the organizers. So in this competition, I was very nervous and was this Malayalam dataset was very new to me. So they solved my issues on time. So because of that only, I was able to do this challenge. Thank you. That's all from my side. And Sukanya, if you can add to this, you can go for it. Okay. I think you can't talk there right now. So over to you, judges. Thank you.
Yeah, thanks, Gufran. Great work. Yeah, so you already
Yes, sir.
showed what improvements are needed, right? So yeah,
Yes, sir.
that's all. Same thing from my side also. Yeah. Yeah. Okay. Yeah,
Okay.
that's great. Yeah. Thank you, Gupta. Yeah.
All right, and next up ahead we have Kesharinath Chaudhary and Pratiksha Naik.
Yes.
Pratiksha is here, I believe. Can you share your screen?
I don't see the option to share my screen.
No, the access is
The
enabled.
permission is given.
There is a green icon in the panel. Can you see?
No, I can't see it.
It's like next to the React.
No, should I leave and join again?
Yeah, you can leave and join. Meanwhile, I think we can take up with
The next.
final participant, right? No, second. Fine. Okay, fine. Gautam, can you check?
Meanwhile, the next team, Aniket Dash and Deva Vasishtha.
Yeah.
You can go ahead.
Yeah, present.
Hello, am I audible?
Yes, Aniket, you're audible.
Hi, so hello everybody. We couldn't, I see everybody has put a lot of effort in this. We couldn't actually do much, but I won't take much time in this. So I shall begin now. So I'm currently in BSc level and Dave is currently ill. And at initial levels he wanted to contribute, but he worked on some open source models, but later on he couldn't talk, so I decided I would take the driving seat and do most of the work. So we can go into the distribution, um, which had mostly false, and like the previous gentleman specified that it had mostly true had one class instance. So I had to upsample it by one, just to split it, split it, and then one thing I noticed that I couldn't determine what was the criteria for differentiating between mostly and partly, but the language structure remains the same, so I didn't bother much. Yes, so the pre-processing was mostly consisting of removing missing values, checking the distribution like all other participants did, and upsampling class instance classes. I didn't try the neural network architecture with SMOT. I thought that would create much confusion, so I didn't follow on that line much. So feature engineering, if we talk about, I added some of the steps like some of the features like TTR ratio, type to token ratio, word count, unique words, just in a desperate attempt to make the model understand better. So primarily I use neural network architecture, logistic regression, and random forest classifier was just to have an idea of comparison. So I'll talk about the neural network architecture more. So we're talking about features. Features, like I said, I vectorized the text using TF-IDF vectorization. I used some n-gram range of 1 to 5. So like all sequences from 1 to 5 were included of length. So I encoded original labels like false, half true, mostly false, and partly false. Split the data set into training and validation. And I used cross entropy loss. Cross entropy loss was chosen for a reason to be, and also known as log loss, right? So it was a multi-class classification. So I used cross entropy loss. It measures the difference between predicted probability distribution of classes and actual distribution, which is just like a one hot encoded vector. So that was the reason behind the choice. So the neural network architecture consisted of 3 dense layers, like first having 512 neurons. There wasn't a specific reason why I chose 512 neurons, but I can say that it's a good balance between model complexity and computational efficiency. So this number allows the model to like capture complex patterns in the data, but without being overly complex. Talking about dropout, I settled with 50% dropout because I thought I wanted to make a robust model which could also improve on macro F1. So applied 50% dropout to prevent overfitting, but didn't work out really well. Activation, if you talk about activation, ReLU and TANH, leaky ReLU, out of which I thought TANH would perform better, but ReLU performed the best out of all these activation functions. And for output function, I use softmax, as this would give us a probability distribution. So the model lacks in robustness. We can see that the macro F1 score were low, but accuracy is okay considering we couldn't do much. So that's all, I guess. I don't have much to add to this. I'm really sorry. I can see a lot of people putting in a lot of effort. I don't mean any disrespect, but I couldn't. So that's it, I guess. Thank you.
Yeah, thanks, Aniket. Great work. So yeah, so at least you try. So that's a big thing.
Thank
Okay.
you so much, sir. Thank you, sir.
And I hope you have learned much more than what we learn in the courses, right? So
Yes, that
right?
was, yeah. Thank you, sir. Thank you.
Yeah, thank you. Yeah, thanks, Aniket.
How to disable this?
I'm like disabling it.
Okay, thank you.
Don't worry, yeah. Good luck, man. Then we have Nitish. Nitish, are you like ready?
Yeah, yes.
Yes, you can start.
Hello everyone, my name is Nitish. I am from diploma level. I am from track 1. So let's begin. Our problem statement was classification of Dravidian language on fake news. So about the training data set, we had major imbalance with false data having almost 73% and some mostly true having only 0.07% in the data set. In the pre-processing and EDA stage, in EDA, I discovered that there was significant imbalance, and in text pre-processing, I did data cleaning and tokenization using TF-IDF. For handling missing data, I used smart and balanced random forest. Yeah, so in other pre-processing step was encoding labels according to the rules, and this is already mentioned. In model selection, I used first model which I used was the basic logistic regression. I used it with SMART. So to handle SMART helped me oversample the minority class. I got the accuracy of 97% on the validation set. So in the train test split, I had done 10% on the validation set and 90% training set. This is the logistic regression algorithm in which it loops kind of over and again over the gradient descent algorithm to find the least cost over the parameters. The second one I used was balanced random forest. So this gave me my best result. It gave me an accuracy of 94%. It had a greater F1 accuracy, F1 score. So in the random forest algorithm, it takes the training set, divides it into multiple training sets, and creates a decision tree based on each training set. And after that, based on voting, it gives us a prediction. This is a random forest algorithm, but I used balanced random forest algorithm in which each training set gets equal number of data from each class so that it can handle imbalance. So in random forest, I didn't use MOT because it wasn't really required. The third model which I used was ensemble voting classifier. For this, I didn't use much, so that was a problem. But I got a 92% accuracy. I just used the previous two models and assembled them together. I used logistic regression and random forest. So this is the algorithm. For each classifier, it will give us a class percentage and will take an average and give us an output. So in my case, there were only two classifiers. So that is an improvement that I see, that if I would have added multiple classifiers, I would have performed well in voting class algorithm. For hyperparameter tuning, for logistic regression, I hyperparameter tuned regularization strength. This helps reduce overfitting, which is a problem I faced. And I used the solvers method. I hyperparameter tuned the solver method, which is used for small data sets. For balanced random forest, I used 3 hyperparameters, which I tuned. The number of estimators, that is the number of random forest, the depth of the forest, and minimum samples required for a split. This is the results. So on validation accuracy, I got 97, 94, and 92% respectively. For the test, I got 72, 80, and 70. In F1 score, I got 31, 63, and 30. So from this, I can deduct that my regression model was overfitting because there is a major difference between the validation and test set. This is little less and it is acceptable. Voting was also more. That means there was overfitting in voting classifier, which is probably because I didn't use many classifiers. So these are the problems and the challenges, improvements I think that we can do. So we can add more we can focus more on increasing the regularization to handle overfitting. And for voting classifier, as I've already mentioned, we can use more diverse models to increase accuracy and reduce overfitting. The challenges I faced was limited training data, which is, as we were given only 1,500 data points approximately. And there was severe imbalance, particularly in mostly true case in which there was only a single data point. Third point is, it being a Darwinian language itself is a challenge that compared to English language, which is comparatively easier to handle. Thank you.
Okay, thanks, Nitish. Great to see. So you have compared 3 models, right? You have tried 3 models. You found that
Yeah.
second one was the best, right?
Yeah, random forest was the best.
Random forest was the best. Okay. Can you show me the parameters? So can you
I
go back
haven't.
to that? Can you go back to that? Selection was there, right? Selection slide something.
This one,
Yeah.
hyperparameter.
Yeah. So for logistic equation, you have here. So, okay, so you have just mentioned this. There was one slide selection. After that, there was one more slide. Yeah, you can see that selection slide, right? Model selection after that.
Yeah.
Overview. Okay, you have just mentioned on that. Okay, great. Yeah.
I've written hyperparameters here. Like I've written in this. I've used regularization and solver method.
That's all. No? Okay. Controlling for overview.
And in random forest, I used number of estimators, maximum depth, and minimum samples required for a split.
Okay, how did you decided this? Which will be optimum for you?
Yeah, I just searched on the net and I found that these are essential when we are using. I use Gits search CV. So in that, I use these parameters for hyperparameter tuning.
Okay, yeah. Yeah, that's great. Thanks, Nitish.
Okay, thank you. How to stop this? How to stop? Okay.
No one is
Okay,
having
thank you.
anything. So we are like left with the final team, that is Pratiksha. So are you like ready now?
Yes, I am. Sorry for the technical issue
No, it's
earlier.
Please proceed.
Can you see my screen?
Yes,
Right.
we can.
Okay, hello everyone. My name is Pratiksha Naik. I'm currently in the last term of my foundation level. My teammate, Keshri, wasn't able to join today, unfortunately, but I will be presenting our presentation today. I would like to clarify that I do not have much experience in machine learning myself. I am still learning and I am still practicing a bit. So most of the work I will be showcasing here is done by my teammate, and I helped a bit, and I'm glad I got to learn quite a lot from this. So our track is detecting fake news in Dravidian languages. In this case, the language was Malayalam. So to talk about the description, our data set was quite imbalanced at first. From the graph, you can see that most of the inputs and most of the data was towards the false class, and only the mostly true class, there was only one instance. So it was clearly an imbalance which we solved by oversampling. To continue, we rechecked the class distribution and we split the dataset into a 90% training and 10% testing for more in-depth taste training. Since we would be getting a testing dataset later on, we decided to focus more on the training part here. Some of the previous models that we implemented before we finalized R1 were logistic regression, which gave us a 71% accuracy. Also in the classification report, the scores were quite low. Other models we tested were logistic regression, random forest, and then SVC. All three of them gave quite low scores. So we tried to optimize the model later on. The final model that we submitted was a pipeline that we implemented of TF-IDF vectorizer. We also used SMOTE, and then we implemented the random forest classifier, which gave us a evaluation and a result of 76% accuracy. For optimization, we also cross-validated the features to find the best hyperparameters from a random sample. For that, we used randomized search CV. We implemented our pipeline into it, and we tuned our hyperparameters accordingly. As I mentioned before, model evaluation and testing, we found a model, we trained it, and the best evaluation that we got was 76%. And this is the model that we submitted. So to clarify about the model that we finalized, we used TF-IDF vectorizer. We used it to convert the categorical into the numerical data, This helped in hyperparameter tuning as we could focus on the words inside the dataset that would help for more accuracy. We also used Smote, which after removing the imbalance, we made sure that Smote helped us in oversampling and making sure that the database wasn't imbalanced as it was before. Since it also used the k-nearest technique, our segregation and classification was also made quite easy. At last, we used the random forest classifier as the model. This model gave the most accuracy out of all the models we tested. And since it works with imbalanced data as well, it was also quite beneficial. Some of the challenges, feature scope, and ideas that I would like to talk about. For challenges, one thing that I personally faced was the nuances of the Dravidian languages. Since I'm not used to it, I'm not familiar with them, it was quite challenging to sort and segregate and to understand which parameters would be important. That is also why we use the TF-IDF vectorizer. The distinction of the complex labels and, for example, the inclusion of the partly true and the partly false classes, it was quite complex and more conditioning was required since it wasn't a binary classification. With the added parts of the above challenges, like I mentioned, the model can work better to identify misinformation as well. So if we consider fake news, we might also consider the probability of there being misinformation being spread while those news are being sent over the internet. So if we consider neural networks or inclusion of web scraping, we can also include in the model a feature that can kind of pinpoint or that can at least put the fake news under a umbrella that classifies about which field or like which part of the news it claims for the news to be fake. And that's it. That's all I have right now. Thank you. Are there any questions?
Yeah, thanks, Pratiksha. Yeah, I think presentation is much clear. No question from my side.
Yes, thank you.
Thank you.
Yeah, so like Shambhavi, can you proceed? Gautam?
Yeah.
Yeah, so we are like done, right? I hope that no other
Yep,
teams.
all of them.
Presentation. Uh, are there any personal doubts for sir? Like anybody would like to ask him any questions
I'm
other
so like
than the
sorry for
ML
sir
challenge or
because it
something
is
like
already like more than it's almost 2.5 hours. We had thought that we would end it in like 2 hours.
that?
So you're on mute. So you're on mute.
So can we
Yeah,
take one or two questions or is it too much?
no, you can ask. If anyone has any question to us, they can ask.
Yeah, I don't think we have any
Doesn't even have any
questions.
question.
So we
All
started with 50 participants and then we just at 26 participants now.
rest are like watching, I think, on YouTube.
YouTube live.
People are watching.
Okay, great.
I think these were all the participants from our team.
So do I have to share the winners today or when?
So I think your take.
Yes, absolutely.
So now we can share or I will share with you or you can share
So you can share it now.
here only.
Yeah.
Okay, great. So like first of all, congratulations to all of you, those who have participated in this challenges. For me, you all are the winners because we have thousands of students in our program and just 300 students participate, right? So that first step toward this particular challenge makes you a winner. Not that you have done the task perfectly, or your accuracy is good. But here in this particular challenge, you have learned how to approach a particular problem, how to follow a deadline given by the organizing committee, right? How to work with the team, right? So all these things also matters, right? Not just what the end result is, right? So for me, all of you are the winners. But for the event purpose, I need to declare 3 winners, right? So what I have done, I have 3 winners from track 2 and 1 winner from track 1. Okay. So I have not focused so much on the technical aspect. Whatever you have shown a presentation, so based on that only I have evaluated. So yeah, and one more thing, like yeah, I am not here to judge anyone. I am the course instructor, so I'm here to help you. So just one suggestion
Don't
from
judge.
my side. Yes.
This is like a lie. So
No, no.
everyone should know. No, no. The thing is that you are the apt one, like to judge this like the session. So for those who like don't know, so apart from being a course instructor, so like sir is also an ex IITian, rather I should say IIT MEN. So
Yeah.
and
Okay. We
also
are running
and
out of
also
time.
no, no,
Yeah,
and
that is
also
fine.
he's yeah, and also he's a Microsoft and a Google like certified educator in the AIML domain. So I think you're apt. That's like
Okay. Great. So just one suggestion from my side. Uh, while you are presenting the screen, like while you are doing presentation, please turn on your camera. Okay. So those who have switch on their camera, they have got 1 extra marks for that. Okay. So this is just a learning purpose. Like whenever you are participating in such events in future, please make sure you turn on your camera. At least when you're introducing yourself for just 10 seconds or 15 seconds, that is also fine. Okay. So that's just one suggestion from my side. And yeah, I will not take much time. So uh, I have 3 winners. First, I will declare for the track 1, I guess. Track 2, right? Yeah. So the team is T32019, Swaminathan C, Vanchit, and Shashinuram. So yeah. So these are the winners. Congratulations, team 32019. Then I
Thank you,
have
sir.
second number is just a second. T22121 Siddharth Roy and Sarfaraz Ahmed. Congratulations, Siddharth and Sarfaraz. And
Thank
the
you so much.
team rank that came first is T094. So it is 94. Yeah, T22094, Gaurav Singh and Sakshi. So great presentation. Approach to the particular problem is also good. So yeah, rank 1. Congratulations to all of you, all the winners and every participants. And just for track 1, we have T017, that is Karthik, I guess. Yeah, Karthik. Congratulations to Karthik. Yeah. So no one is clapping. I will clap.
yes,
Okay.
I, yes, I am.
Reaction.
Yeah.
Okay. Great. Great to see such participant. I know you have quiz in between, but still you have managed to complete this challenge. So really appreciable. Okay. So thank you everyone. Thanks for inviting me once again. Yeah.
Thank you a lot, sir.
Okay, sir.
And I also want to add that Advait, like one of the co-organizers, like couldn't join like due to his AppDev 2 like project. So he's also one of the co-organizers.
Yeah. Okay. Great.
That's it, I think, like pretty much. Shambhavi, you can conclude. Thanks a lot, sir, like once again for accepting invitation and coming and like staying with us for more than 2 hours now.
Yeah, that is fine. Not an issue.
Right. I would just like to reiterate what Soma said. So thank you so much for all your valuable insights, and heartiest congratulations to all the participants as well. All of you have done quite a great job, and we as organizers only hope that you have that we have a giveaway to give to you. Even if you are in the foundation level, uh, we hope that when you reach to the diploma, you have something valuable that you have learned from this challenge ahead with you. That's it from my side. Thank you so much, sir. Thank you so much for joining. You've always been a part of the Logic Loom team for us as well, and we have quite a history with you. So thank you so much for being a part of the ML challenge as well. We couldn't have asked for someone better than you to take this position. Thank you so
Yeah.
much.
Yeah. Thank you. Thank you, everyone.
Thanks, Lakshya.
Right. I think we can stop recording now.
Yeah, I think we should stop. Fine. I think so, like we can leave. It's fine.
Okay.
Yes,
Thank
sir.
you. I will leave now. Yeah.
Thank you, sir. Thank you so much.